In assertion, given function f of x is equal to mod x plus mod of x minus 1, where x is a real number, and it's also mentioned that f of x is not differentiable at x is equal to 0 and x is equal to 1. Let's check this through the graph. Given f of x is equal to mod x plus mod of x minus 1, let's break into 3 intervals. Whenever x is greater than or equals to 1, so both the modulus are positive, so x plus x minus 1, which is equal to 2x minus 1, we can write. And when x lies between 0 and 1, so mod x is positive x and mod of x minus 1 is negative. So we can write x minus x plus 1, which is equal to 1 constant you are getting. And whenever x is less than 0, so both are negative. So minus x minus of x minus 1, which is negative 2x plus 1. So we can define the function as whenever x less than 0, so the graph is minus 2x plus 1, and when x lies between 0 and 1, it's a 1 constant function, and when x is greater than or equals to 1, so we can say the graph is 2x minus 1. Let's sketch the graph here. 0, 1. From 0 to 1, the graph is constant, so it is 1. So at x is equal to 0, it is 1, it is included, and 1 here. And x is greater than or equals to 1, we can see the graph 2x minus 1. Say this is 1 here, function. At x greater than or equals to 1, 2x minus 1. So when x is equal to 1, it is 2 into 1 minus 1, 1. And x is equal to 2, 2 to the 4 minus 1, 3. Since it is a linear equation, it is a straight line. You will get. So here is the graph 2x minus 1. And here it is 1. So y is equal to 2x minus 1, y is equal to 1. And below 1, below 0, we can see negative 2x plus 1. So when x is equal to 0, it is 1. When x is equal to minus 1, it is 3. So we can see the graph here. Minus 1, it is 3, same as plus 2. So this function is y is equal to negative 2x plus 1. And clearly we can see that in the right derivative, y is equal to x minus 1. At this point, the derivative is y dash is equal to 2. And here at this case, the y dash is equal to 0 for y is equal to 1. And here in this case, y dash is equal to negative 2. So at the point x is equal to 1, the left derivative is 0 and the right derivative is 2. So this is left hand derivative and right hand derivative. Both are not equal, and hence we can say that at x is equal to 1, at x is equal to 1, it is not differentiable. And at x is equal to 0, we can say the left derivative is minus 2 and the right derivative is 0. So here also we can say that at x is equal to 0 also the given function is not differentiable. And hence we can say the assertion given is true. And also we can also mention that these are the two corner points. We are getting a corner point, sharp edge. At these two edges, there is no differentiability. So at 0, at x is equal to 0 and x is equal to 1, not differentiable. And the reason given, suppose f be a defined and continuous on open interval a comma b, and for c belongs to a comma b, f of x is not differentiable at x is equal to c if limit h tends to 0 minus f of c plus h minus f of c divided by h. This is left hand derivative formula, and which is not equal to limit h tends to 0 plus f of c plus h minus f of c divided by h, which is right hand derivative. So left hand derivative is not equals to right hand derivative, it is mentioned. So accordingly, the assertion also we got the same. Left hand derivative is not equal to right hand derivative at the 2 points x is equal to 0 and x is equal to 1. So we can say the reason is also true, and this is the correct explanation of the assertion. So option A is the answer.